6.4, number 5. Find the present value of an annuity of $6,000 paid at the end of each 6-month period for 8 years if the interest rate is 8% compounded semi-annually. So after present value, so that's what's unknown, we want it to generate payments of $6,000 on a regular basis. They're paid at the end of each 6-month period. So that's semi-annual. So talking about 2 periods per year. The total length of this is 8 years, and the interest rate is 8%. So we want that as decimal. And now we need to compute some values. So first, what's our n here? Well, that's 8 times 2, so we have 16 periods. And what's the interest per period? That's 0.08 divided by 4 to give a divided by 2 to give a 0.04. And we're looking for present value, and it is an ordinary annuity. So, and because it's present value, we have the negative here. So you put the lump sum in, and it's going to generate each of these. It's going to grow into the payments and spit 16 payments of $6,000 out. Okay, so we're looking for A. We have R, we have I, and we have N. So at this point, just plug it in and compute it. So A is going to be 6,000 times this growth term. So we just plug all these numbers in here and start computing. So 6,000 times 1 minus 1.04 to the minus 16 over interest per period. So again, because this is negative, this term is going to shrink. So it's 1 minus 0.53. Keep all the decimal places in the internal calculation. Okay, so 0.447. It's 66. Anyway. Okay, so divide this number by the interest and multiply by the payments. So 11.65. So 6,000. So 69,913.7736.5. Okay, now round. So 69,913.77, and so that is the starting amount that you need in the for the annuity as at the present time. Okay, and so this is going to generate, just so you're aware, so it's going to generate 16 payments of 6,000, which is going to be more than this amount over time. Yeah, so it's going to end up generating $96,000 total for an initial input of just under 70,000. Okay, so that's just important to be aware of.